stream.
Yeah,
Okay,
the
okay.
YouTube always takes a minute.
Yeah, sure, no problem.
Fabulous. Well, I think we're ready to roll now. So thank you everyone for joining us yet again for another brilliant Monsoon seminar series. So before we get started today, just remember that if you have any questions, to please type them into the chat. And then at the very end of the talk, we will read them out and call on your name to see if you would like to ask the speaker a question. And so today we're having a seminar from Praveen Mishra from the Cluster University of Jammu. And Praveen is from an earth science background who specializes in paleoclimate studies using a multi-proxy approach. Presently, Praveen is an assistant professor at the Department of Geology, School of Sciences at the Cluster University of Jammu in Jammu and Kashmir. But Praveen previously did his PhD at the GFZ in Potsdam, Germany, and spent some time at the Free University in Berlin, Germany. So without further ado, Praveen, will you please share us today some of your research?
Thank you very much, Tara, and good afternoon, everyone. Actually, thank you very much for such a nice introduction. And actually, I've been following this monsoon series since a couple of months, and I've been observing that so many people have already presented their views on monsoon variability, and they've used different archives, they've used different methodology to understand the monsoon variability in the past. And they have their own opinion, like why the monsoon is varied in the past, what are the factors, what are the controlling factors, and all these things. So in today's presentation, I'll be discussing about the monsoon variability in the Indian subcontinent. And I will be using case studies from two different lake systems. One is from the northern Himalaya, northwestern Himalayan region, and another one is from the central India. So I'll be discussing about why there is a synchronicity or asynchronicity of the Indian monsoon variability, the spatial temporal variability of the monsoon system in India. So, as you all know, aware that the India has a very big population, right? And it is one of the second most populous country in the world. And to sustain this economy, to sustain this population, you need a stronger economy. So, in Indian sector, there are three dominant economical sector. One is the service sector, industry sector, and agriculture sector. Among all these three sectors, the agriculture is most impacted by the monsoon variability or the rainfall variability in the Indian subcontinent, right? So it actually contributes approximate 1/3 of the GDP or the gross domestic product of Indian economy. So whenever there will be extreme rainfall or whenever there will be a drought-like condition, this directly affect the agriculture productivity. And since the agriculture productivity is dependent on the monsoon variability, so this also directly or indirectly affect the Indian economy and hence the population of the Indian subcontinent, livelihood of Indian subcontinent. So there are so many studies have been done in Indian subcontinent to focus on what are the factors which affect the spatiotemporal variability of the monsoon and rainfall, what are the factors of the increasing in the extreme climatic condition, what will happen in the future in terms of extreme climatic conditions. So all these records have shows that just one second, yeah. In the Indian region, there is a monsoon variability in the global warming scenario. Some has shows that there's spatio-temporal variability in the rainfall. Some studies has shown that there will be an increase in the wet and the dry spells of these extreme climatic events, extreme wet-like condition, extremely dry condition, right? So for example, here, if you look at this diagram, I'm sorry, I've just put all the figures into one slide so that you can able to understand how the monsoon is varied in the past. Like these all are instrumental data sets, And based on all the instrumental data set, you can see here there is a spatial temporal variability in monsoonal precipitation. And these data are from the same month, but from the different year. For example, 65, 66, 68, something like that, right? So there is a spatial temporal variability in the monsoonal precipitation in the Indian subcontinent. And the outcome of these results have indicated that there will be increasing spatial variability in the Indian monsoon. These extreme events will be increased, and also there is a heterogeneity in the extreme monsoonal rainfall. All right. So all these information are basically based on the instrumental data set. It covers mostly, I think, 150 years maximum. So if you really wanted to understand the climate variability, then you need a more data sets. You need a data set which goes beyond the instrumental era, right? In the instrumental era, human influence also has some significant role in causing the climate variability. But if you go in the past, before instrumental era, then the role of human influence is extremely low. So all the climate variability you've been observing, and that is mostly because of the change in the natural climatic factor, natural forcing factors. So to understand these longer data set, to understand the climate variability beyond the instrumental era, you need a longer data sets, right? And there are so many archives, so many very nice archives are available, and so many nice groups have been already working on these different archives. For example, marine sediments, lake sediments, speleothems, tree rings, corals, and ice cores. So using these archives, people used to reconstruct the past climatic variability. So like I've been continuously working on the lake sediments. So in this presentation, as I already told you, like I'll be discussing about lake sediments from northwestern Himalaya from this region, and the central Himalayan from this region. So all these lakes I've been in the Indian subcontinent, I'm continuously working on. Some of the in this study in this study areas, or in these lakes, I'm working on a different time scales. As for example, in some of the lakes, I'm working only on like 100 years of data sets. In some other lakes, I'm working on the last like 2000 years, and some of the result on some of the lakes, I'm continuously working on the long term to generate the long term data sets, right? So before going into details, I would just like to shortly discuss about the working methodology while working with the lake sediments, right? So suppose this is just a diagrammatic representation of a lake basin where it's surrounded by mountains, and this lake is impacted by or influenced by atmospheric precipitation in terms of rainfall, in terms of snow, atmospheric pollutants, streams, stream water, glacial meltwater, urban area or anthropogenic activities, vegetation in the catchment, vegetation in the lake basin. So the lake composition of these lake sediments is the cumulative impact of all these factors together, right? And to decouple the dominant factor which affecting the sediment composition, you need a certain kind of proxies. So while working with the lake sediments, our study is broadly divided into two parts. One is to just to generate a proxies, to test the proxies, to calibrate the proxies according to change in the modern environmental condition. And once we do that, once we test it, or once we develop a proxy, then use those proxies to reconstruct the past environmental condition. So basically, it's a two-dimensional approach. One is the proxy generation, the another one is the reconstruction of a past climate variability using the proxies. So once we analyze all the samples in terms of different proxies, for example, inorganic geochemistry, organic geochemistry, historical data, geology, then we combine all these things together, and then we can able to understand the past climatic study. So this is just a basic information like how we approach while working with the lake sediments. All right. So now coming to the study area, like I said, one of the lake I'm working on, I'll be presenting is the lake from northwestern Himalaya. It's the Somoreri Lake, and the another one is a small lake situated in the central India, right? So now you can ask me like why you have selected these two areas, right? So the purpose to selecting these two lake basins is there are actually multiple reasons. The first reason, and most important reason, is that these two lakes are situated in two completely different climatic regions. For example, Somoreri is situated in the northwestern Himalaya, which is influenced by the ISM and westerlies. Lonar Lake, situated in the central India, is only impacted by ISM, Indian summer monsoon, in a southwest monsoon precipitation. Another point is that in these two lakes, we have a continuous Holocene record. The third point is, as compared to the Lonar Lake, Somorari is extremely high, extremely a large lake basin. It covers approximate 150 kilometers square area. Lonar Lake is very small. It covers only a few kilometers square area. Also, the precipitation, the amount of precipitation is also contrasting in these two regions. While Somorari is situated in situated in rain shadow area, which receives very less rainfall, and receives very less rainfall. However, Lonar receives extremely high precipitation. So these two contrasting lake basins can help us to understand why there is a synchronicity or asynchronicity in the climate record in the past. Right? So coming to the first point, here I am just presenting a geology of this catchment of the lake basins, because as I said earlier in the previous slide, the composition of lake sediment is also dependent on what kind of a rock or what kind of a lithology is present in the lake catchment, right? So in Somorari, the lithology or the geology is very complex as compared to the Lonar Lake. In Somorari, we have a carbonate, we have a granitic gneiss, we have a granitic rocks, quaternary sediments, and all kind of geology you can just find out in the lake catchment, in the Somorari lake catchment. However, with respect to Somorari, Lonar Lake is situated in the Deccan Volcanics. So the catchment is only dominated by the basaltic flow. So here you can see that this composition, this geology is also impacting the lake sediment composition, right? Now, this is just a working approach I have already discussed with you earlier. Like in the first step in the proxy development, we use different proxies. We use different tools to understand which proxies can be used to understand the future past climate variability in the region. So in this study, we will use a hydrochemistry, geochemistry, and the isotopic investigation. We will do all these investigation to understand which proxies can be useful to understand the modern environmental, to understand the impact of modern environmental condition on the lake basins. And once we develop these proxies, we'll use those proxies for climate reconstruction, right? Now coming to the Somorari, here I'm just using some of my results from like I have analyzed the water samples from different regions, and for example from the stream water samples, lake water, lake remnant water. And what interesting thing which we have found here is that the calcium and magnesium values is extremely high especially the calcium is extremely high in those sample which is situated in the carbonate terrain, right? And also we have used the magnesium by calcium ratio, which is as compared to other lake basin, it's extremely high. In most of the lake, if the lake is freshwater, then you will get magnesium by calcium ratio. It goes around 1, 1.1, 1.2, 2 or something like that. But here in case of Somorari, these magnesium by calcium ratio is extremely high. That goes up to 20, 16 or something like that. So the higher magnesium by ratio in the space, and also these magnesium by calcium ratio is extremely high in the lake water and also the residual water. So the high increased magnesium by calcium ratio is indicating that the lake is evaporative in nature. Okay, so this is just a first evidence which indicates the lake is evaporative in nature. So we've also compared our result with the remote sensing data sets, which has already been published, I think in 2015 or 14 or something. And they are also showing that in the modern day scenario, the lake is evaporative in nature, and the lake level is continuously going down. And I think it's at the rate of 0.119 centimeter per year, something like that, right? So we've also used another, okay, so this is just a conclusion of the first part, the hydrochemistry, that the hydrochemistry of the stream water samples is controlled by the catchment geology, and the high magnesium by calcium ratio is indicating the evaporative condition in the basin. So in addition to this, we have also done the hydroisotopic investigation of the water samples from the lake and their catchment. And we found that the lake water shows the evaporative enrichment as compared to the stream water samples. So stream water samples is lying somewhere here. It shows very depleted value. It's similar to the snow melt, similar to the snow samples, which indicates that the stream water in the Somorari region is mostly coming from the glacial melt, right? So this is just another evidence which shows that lake is evaporative nature. So we've also done some geochemical or mineralogical investigation of the catchment sediments, which indicates that the siliciclastic material, for example, quartz, muscovite, plagioclase, are mostly dominant in the northeastern, southwestern part of the lake. However, the southern part and this eastern part of the lake is dominated in the presence of a calcite, right? So similarly, we have also done the mineralogical investigation of the lake sediment samples. And interestingly, what we found here, if you look at this diagram, this catchment mineralogical distribution, you'll find that there is just some specific region which shows the higher concentration of siliciclastic material, right? Like in the northern region and also in the southwestern part. However, in the lake cement, there is no any significant trend of these siliciclastic minerals. Also, in contrast to the catchment, we have also found a aragonite mineral in the lake segment, which is not present in the catchment. So the presence of aragonite is itself indicating it's orthogenic precipitated in the lake, and is mostly you'll find in the lake with evaporative in nature. So based on multiple evidences like high magnesium by calcium ratios, aragonite, presence of aragonite in the lake sediments, enriched value, and also we have done isotopic investigation of the bulk carbonate from the lake sediments, and also compare it with the rock samples from the near the catchment. As I said earlier, the catchment is dominated by carbonate rocks. Lake sediment shows the evaporative value. So based on these information, based on these output, if I conclude this first part of the proxy development from the Somorari Lake, this indicates that all this information are pointing towards one thing, is that the lake is evaporative nature. So we can use these proxies to understand the past hydrological balance in the region, because the evaporation, inflow, and all these factors like inflow versus outflow. So here the inflow is mostly in terms of rainfall or maybe glacial melt. Outflow is in terms of evaporation only. So this hydrological balance we can study based on only based on these proxies, right? So now coming to the Lonar Lake, here also we have done some proxy development. This is a very small lake, and also we have done the hydrochemical investigation. We found it lake water has extremely high sodium and chloride concentration as compared to Somorari, and also the stream as compared to stream water from near the catchment. This also indicates that the lake is evaporative in nature, because of the presence of sodium and chloride in lake water. You'll get only when there will be a very high concentration of very high evaporative condition, right? So we have also done hydroisotopic investigation of the lake water, which shows the evaporative in nature. Interestingly, in this lake, we have found interesting mineral, that is a gallusite mineral, right? And in Somorari, if you remember, we have found aragonite and calcite as an orthogenic mineral, but here in Lonar Lake, we have found gallusite as an orthogenic mineral. So gallusite is actually nothing but it's also an indicator of a evaporative condition. However, the presence of gallusite is indicating it's even more evaporative as compared to the Somorari Lake. So in terms of progressive evaporation of a brine water, there is a specific trend, or already this trend is already well established before. The presence of a calcite and aragonite, if indicating is the evaporation process is just started, and after progressive increase in the evaporation, you will find a gallusite, dendrona, and the halite. The sodium and chloride concentration will be extremely high in such kind of situation, right? So the presence of a gallusite crystal, we've used the presence of a gallusite crystal and the carbonate isotopes to understand the hydrological balance in the Lonar Lake. So we have used almost same kind of proxies in these two lakes, so that we can able to compare these together. So this is just conclusion of a second part of lunar, like lake is evaporative in nature and the presence of a galosite and foraminers indicating evaporative in nature, and also the water isotopic value is indicating that lake is evaporating. So now coming to the climate reconstruction part. Okay, in first part, we have already established that which proxies we can use to understand the past hydrological condition in the region. And now coming to the climate reconstruction, right? So in Somare region, we have reconstructed a chronology based on bulk organic matter and macrophyte fragments. And we have reconstructed, we have established a chronology which goes to up to 23,000 years, right? And the only, actually, there is a slight problem. I wouldn't say use the term problem, but there is a uncertainty associated with this chronology. Uncertainty in terms of hard water effect. So in such region where the catchment is dominated by the carbonate terrain, uh, if you date the modern sample, for example, we have date the modern samples, bulk organic matter, the age of the modern sample, which should be comes at around 0 year, it comes at around 3,000 years. Living Potamogeton species, the age of this living Potamogeton goes to around 740 years. So we have corrected the already corrected our chronology based on already published papers. We have used a methodology which is already being published and is commonly used in all the lakes in the Ladakh region, in Ladakh region, and also in the Tibet region, because this is actually a common problem in the whole Tibet area. So you will find any paper, you will find any work from these region, they have already discussed like how they have reconstructed their chronology if their dates are impacted by the hard water effect, right? So we have also analyzed bulk isotopic composition from the lake sediments, from the Somare core sediments, and we found that there is extremely high correlation between delta 18O of bulk carbonate and delta 13C of bulk carbonate. So this also indicates the lake is evaporative closed basin. So we have used all this information to understand the temporal evolution of a proxy's behavior in Somare region. So here I have just compiled all the data from Somare region. This is 18O, 13C carbonates. Then titanium concentration also we have measured, which indicates the surface runoff. So whenever the titanium concentration is extremely high, if you remember, there is a siliciclastic sediments also present in the lake. So titanium is a conservative element, which also indicates the presence of high superficial runoff in the region, right? So we have used titanium concentration as an indicator of surface runoff. Then we have also used the relative abundance of orthogenic minerals, that is calcite and aragonite. And also I compared the same results with already published pollen record from the Somare region. So they have used a pollen record. They used A by C ratios to reconstruct the mean annual precipitation of the region. So based on these information, we have reconstructed the past hydrological condition in the region, and where you can see that during around 11.2 to 8.5 cal Ka, there is almost no carbonate concentration, and the titanium concentration was extremely high. And also based on the pollen abundance, you'll find that the precipitation was extremely, mean annual precipitation was extremely high. So we coined this area as an early Holocene wet phase. However, if you look the carbonate data set from from 8.5 to present day condition, it shows continuously increasing trend, right? And the same thing also you can observe from in 13C, and also in titanium concentration is going down. And the relative abundance of, for example, if you look the calcite concentration from 8.5 to around 5.5 cal K, the calcite concentration is increasing, and after 5.5 to 2.5, it increased suddenly, right? Like in this third zone. And after certain time, the aragonite precipitation gets started. So this region from 2.5 to present day condition, 2.5 to 0, this represents the present day condition of the lake, where we are getting aragonite concentration, we are also getting a calcite concentration, carbonate concentration, carbonate isotopes also shows the evaporative condition, and we have a low titanium concentration. And in addition to this, we have also found using the mean annual precipitation record from the based on the pollen, they also showed that there is a low precipitation as compared to the early Holocene. So we have reconstructed the hydrological balance, the past hydrological condition in the region, right? Now coming to lunar core sediments, this chronology is, as compared to Somare, is relatively well established, and there is not much uncertainties associated with, because there is no hard water effect in this region. So they've used we have used different proxies to understand like past climatic condition in the region. And if you closely look at this look at this core sediment, this white points is indicating the presence of gallicite mineral. So based on these gallicite mineral, we have identified two drying phases at around 4.2 and at around 1.5 to 2 or something, right? So we have used the hydrological changes in Lonar Lake, and we compare this result with Somorari and other regional records to understand why is there any. The first question is there any spatio-temporal variability in the climate record in the past? And if yes, then what could be the factor, right? So here I have just used the hydrological changes in the Lonar region. Blue indicates better climate, and the orange indicates extremely evaporative condition. Then this is the carbonate mineralogy from Somare region. Then I have also used the bulk isotope bulk carbonate isotopic value from Somare. Then I again compare this result with the surrounding lake record from Selinco and Namco. These two are situated in the Tibet region, and then I compare these records with the solar insolation and also average moisture index from the Eris Central Asia, right? So actually, this Eris Central Asia is governed by westerlies only. So we have just compared our result with the Eris Central Asia climate record moisture curve, so that we can able to understand how westerlies change in the past. So if you look during the early Holocene wet phase, Lonar, the wet phase in Lonar goes up to 6.5 or something like that. But in Somorari, it goes only until 8.5. And also the same climatic record you will also find in Selinco, in Namco as well. However, in the Central Asia, Eris Central Asia, the moisture course indicated a relatively low moisture condition. That means during this phase, the insolation, the monsoonal precipitation was extremely high. However, the role of westerlies is extremely low in this particular region. Although this location, this Somorari location, is already in a present day condition is situated in the rain shadow area. That means during that time, that period of time, during at around 8.5 to 11.2, the monsoon, the intensive, this region was relatively wet because of the intensification of a monsoonal condition in the region, right? So we also compare our another thing which I just forgot to mention here. If you from 8.5 to 11 to modern day condition, if you move from this part to this part, you'll find that there is a progressive increase in the drying condition. In Somorari, we have found it in also in the Selinco, we found it, the titanium concentration is going down in Namco, indicating low rainfall, right? So, and also the insolation curve is going down, indicating low monsoonal condition in the region. But at the same time, these two drying phases, for example, at around 1 Kelk and at around 4.2 Kelk, is not visible in any record from the Tibetan region, right? So if you remember my introductory slide where I mentioned that Somorari is contributed by, or the hydrology of the Somorari is nowadays is controlled by snow melt from the region. So this could have been one of the reason that they may have just diluted that effect of a drying trend in this particular region, right? And also since there is a age uncertainties in these records, so it's I mean, it's less, I would say, I can say with the less confidence that okay, these records can be able to, like, we can able to represent this drying phase in all the records in the Asian region, right? Now, I compare our record with other global record as well, some marine records from Arabian Sea, then Bay of Bengal, then Kumph Cave, and the titanium concentration in the Kariako Basin. And also I have just plotted here the increase in ENSO activity because of the space, I couldn't able to put that curve here. So I just mention it here that the ENSO activity is continuously increasing since Holocene to present day condition, and also the monsoon and rainfall is going down, right? So if I compare all these records together, then these drier phases, for example, these 11 point around 2 kLK, around 4.2 kLK, and also there is a record at around 2.5 kLK. All these records are not synchronous in each and every climatic records, right? But if you're talking about the longer climatic variability, like early Holocene wet phase, then drying phase, and then the modern day condition, you'll find almost the same kind of results in all the records. But there is a because of the chronological uncertainties, there might be some chance that okay, in some record we'll find the early Holocene phase between 11.2 to 8.5. In other record, they shows the 11.5 to 6.5 is some climatic record. So there is some spatio-temporal variability in this climatic record. For the longer climatic record, okay, these all behaving similarly, but for the shorter climatic event, there is a spatio-temporal variability in the climatic fluctuation, right? For example, here I've just used different climatic records, and I've just used the bar diagram for all these climatic records, and I've divided the records into different zones. For example, like Northwest Himalaya, the Northwest India, and then in the Gangetic Plain, the Central Indian record, and the Northeast Indian record. So if you compare all the record from the Northwestern Himalaya, where Somurari is situated, the early Holocene is wet in almost all the lakes. Okay, there is some drying phase also observed, but if you're talking about the smaller event, the shorter event, there is some spatio-temporal variability, right? So this could be this could be because, especially if you're talking about the same zone, like if you're talking about the Northwestern Himalaya, there is spatio-temporal variability in terms of a shorter time scale, because here people are using, or the working groups are using different proxies. Like Demske et al, they've used pollen. Rawat et al, they have also used pollen. Bhushan et al have used geochemical concentration. So, and Sahiya, this is a speleothem record. So 2 points are very important to mention it here. First, if you so for example, each proxy has their own limitations, right? And it's very important, if you need to establish the response of each proxies in a modern day environmental condition, and then you can use those proxy for paleoclimate reconstruction, right? So this is actually the problem in some of the region, why there is not a space, they are not synchronous, especially in the shorter time scale, because there is a lack of a calibration of a proxies in a certain region, right? And also the sensitivity of each proxy is completely different, right? Pollen is respond in a different way, and carbonate isotope behaves in a different way. So that's why in this presentation, I've used almost the same climatic record, almost the same proxy, so that we can able to clearly understand, since these two proxies are behaving similarly, so we can compare if there is an uncertainty associated with each data sets, right? So here also we have just compared everything, and based on this comparison, based on this investigation, I could just say that there are so many factors which might have caused the spatio-temporal variability in the climate record. First is moisture source. Okay, for example, in Northeast India, this is mostly, this is not mostly, but this is only controlled by southwest monsoon precipitation, right? Some of the records shows that the northeastern monsoon, the precipitation pattern in northeastern region is governed by the ENSO events. However, other model studies they are showing that there is no such connection with the monsoonal precipitation in Northeast India. Right? So there is some uncertainties associated with the modern data, uncertainties associated with the proxy data. So for those kind of studies, we need a detailed understanding. We need a detailed study from each study, from each region. For example, if you are focusing on the Northeast India, then we need a detailed modern investigation, and then based on modern investigation, we need to understand the past climatic variability, right? So also the role of teleconnection is completely different than local climate variability. For example, in Northeast India, the precipitation is extremely high as compared to the central part of the India, even in the even in the modern, normal monsoonal condition, right? So these factors we should include in our study, and once we include all these information together, then based on this we need to understand the behavior of each proxies in each and every lake basins. And once we know these information, then we can decouple all these factors together, like which could be the dominant factors which affecting the proxy behavior in the region. So if I conclude the whole presentation, then there is some spatial temporal heterogeneity in the climate record because of the local environmental condition, because of the moisture reserves, proxy sensitivity, chronological uncertainties, teleconnection, anthropogenic impact in the region, right? And as compared to the Lonar Lake, like in Lonar, we have found in the central India record, we have found drying event, multiple drying event, which is not visible in the northwestern Himalaya because these regions are less sensitive to drought because of the buffering effect of snow vault and weaker late Holocene ISM in the region. And also, except during the early Holocene, when the Indian monsoon played a major role in higher or inflow versus evaporation, the hydrological budget of Somore Lake has been largely controlled by the meltwater inflow. So these are all information. These all are points which I would like to conclude for this presentation. And of course, there is some lag in the paleoclimate studies from the Indian region. I would say that because of lack of a modern understanding of the proxies and the calibration of proxies in the region, and for that's why it needs to be studied in a detail. It's not like that you go in the field, just collect the sample and do the paleoclimate analysis. No, you need a proper understanding of the lake basin. You need a proper understanding of the proxy behavior. You need a proper understanding of the impact of anthropogenic influence in the lake basin. Once you understand the lake, then in that case you can able to do the paleoclimate analysis. And I think that is my last slide. And thank you very much for your patience. Thank you, Tara. Thank you, Professor Clift. And yeah.
Great. Thank you so much for an excellent talk.
Yeah. Thank you, Tara.
Yeah, I very much enjoyed your conclusion slide because I think that lakes are very complicated. And you did a nice job of summarizing that and some of the promises and pitfalls, of course, in lake systems. So let us go to the audience and see if anybody has some questions. So I already see in the chat that Peter Clift, you have written a couple of questions. Peter, would you like to ask your questions out loud?
Sure. I wondered, so as you were pointing out, not all the lake records seem to show the same sort of history. And, you know, and you were worrying if that was because of the proxies not being properly calibrated locally, and I wondered if some of it may just be related to age control, maybe where the age control isn't good enough to be able to correlate. I guess I was particularly surprised to see differences between Sokar and Somariri because they're so close to each other. I mean, it's strange that they wouldn't be the same.
Yeah. Actually, this one point I've already mentioned in the conclusion slide, that the chronological uncertainties is also very important part while working with the lake sediments, right? And since Soaker and Somerary results are largely they are overlapping, but for the some sort of small scale, for example, in Soaker, they mentioned that there is also mid Holocene wet phase, which is not visible in our record, right? So this
Right,
could be one of the
exactly.
reasons. Yeah, so this could be one of the reasons why, because they've used a single proxy analysis. Single proxy means they've used just a pollen analysis, and we have used a multiple investigation. We have done the multiple investigation, and based on that investigation, we just concluded that there is not there is no any mid Holocene wet phase, but since early Holocene, there is a progressive decreasing in the monsoonal rainfall, and which is also evident from the pollen record. So I'm not saying that this could be actually because they are using only a single proxy. So there could be
Yeah.
reason that they found some another like some other indicator of the pollen, so that which indicates the wet phase also. So this could be one of the factors. So one thing which I forgot to mention here, I mean, I'm not sure about other archives, but especially in the lake sediments and the lacustrine archives, you need to do a multi-proxy investigation. Why multi-proxy? Because if you are only using suppose carbonate isotopes, right? So carbonate isotopes is also depending on the so many other factors. So if you're just only using the carbonate isotopes, you cannot able to understand the error associated with those proxies. But if you are using a carbonate isotopes with the other and compare carbonate isotope with the other geochemical proxies, then you can able to understand the error associated with these proxies, and then in that basis you can able to clearly understand the climate variability in the past and also their behavior in the modern day conditions.
Okay.
Yeah.
I mean, I guess I had sort of similar concerns about that sort of wetter phase you were showing at Lona Lake between about 4,000 and 2,500. But anyway, maybe it's good to ask. Someone else can ask a question. Thank you.
I see that Gaurav Srivastava, you have raised your hand. Would you like to ask your question? Your mute is on.
Oh, yes. Sorry.
Oh, good.
Actually, this is just not a question. This is just, I want to clarify that sometime the region Ladakh, where the Somerary Lake is there, sometimes it is called as cold desert. Some people believe that it is not a cold desert. So I just want to know about your opinion, whether it is a cold desert or not.
Frankly, I am not aware with the technical term with the cold desert, but one thing I can say that, okay, the presence, because okay, if you compare with the desert like Rajasthan desert and all this thing, then there is no much rainfall in the present day condition in Somerary region. So that's why they are termed as a desert. And cold desert because of their extremely varied temperature in diurnal temperature. So that's why they are called as cold temperature in present day condition, right? But if you compare present day condition with the past, like paleoclimatic temperature or paleoclimatic condition, like during the early Holocene wet phase, as I showed you earlier, like during that particular time, the monsoonal rainfall, I mean, that particular region was impacted by the huge monsoonal rainfall, right? So during that time, this region was shouldn't be considered as a cold desert, but that region receives a normal precipitation as compared to the present day condition. So now this is considered as a cold desert, but during like past 11,000 years or 8,000 years, this region wasn't the part of the cold desert. Yeah.
Thank you.
Thank you.
Are there any other questions from the audience? I have more of a comment related to your prior question that was asked by Peter, and why maybe the records between Somorari and Sokar could be different. I mean, they are close, but there is quite a bit of topography also between the two lakes. And if you've got essentially the monsoon essentially trying to essentially go through there, which I mean, it's like at least I think 100 kilometers, isn't it? Or at least 70 kilometers between the two
even
lakes.
less than 100, I guess. Yeah, it's even 100, less than 100, I guess.
Yeah, so it's still quite a bit of distance to go with just the bit of monsoon that gets in there. I mean, in addition to everything that you talk about.
These two regions are not that much far away in terms of impact of monsoonal rainfall. But the point which I'm continuously saying, this could be maybe because the use of the proxies, within 100 meters, okay, within 100 kilometers, there might be a chance that there is some local effect also affect the precipitation in that region. But you're not talking about 1 year or 2 years, right? You're talking about like 1,000 years or so. So within 100 kilometers, if there is not much altitudinal difference, okay, if there is altitudinal difference, then I can able to understand this could be one of the reason why there is in one region you are getting high precipitation, another reason you are not getting high precipitation, right? But you're almost, these two regions are almost situated on the same altitude. I'm not sure exactly, but I think there is not much variation, right? So technically these two regions are situated like in the same geographical region, in the same climatic region. The only thing which is different between these two is the proxy which you are using to understand the climatic variability. I'm not like criticizing those results, because that result is extremely it's one of the first result from that particular region, and it matches well with all other global records. But still, and even in the present day condition, even in Indian subcontinent or in other records also have been reviewing so many papers, they are only using a single proxies. So using a single proxy, it is very difficult to understand the past climatic variability, right? Also, because in Sokar they have also done the calibration of the proxies. So in that part there is no problem, there is no issue. But still, if you're, because see, the pollen investigation, I'm not expert in the pollen investigation, but one thing I can able to understand, like these investigation is based on the counting of pollens, I guess, right? So even in few slides, if you have just done some mistake, then the climate will become like from dry to wetter environment, and this could possible in anywhere with anyone. So I'm not denying that their record is completely like this is opposite or something like that, but this could be one of the possibilities, right?
Yes,
if maybe in future I'll go there and I'll use some another proxies for climatic reconstruction. Then if I'll find the same thing, then I'll say accordingly.
More data.
Yeah, then I need more data sets. Yeah, exactly.
Excellent. And so before, I have another quick, very, very quick question, but I want to see if anybody else from the audience would like a chance to ask one before I finish us off here. Gaurav, is your hand still up? Did you want to ask another question? Okay, I was just checking. So I guess, again, just quick question. And did you find any evidence at all for neotectonic activity in your short timescale lake record? Because I know that there are some people that argue there is neotectonism around some of at least your higher altitude lakes. But whether it's on that time scale, I'm not sure.
No, actually, from in my lake record, I haven't come across with such evidences. But one of my colleague, he worked on the sediment profile from Spiti region. It's situated even more southern part of Somorari. And in the sediment profile, he found out some nice this geomorphological indicators which gives you information about the neotectonics in the region. So that paper was already published, I think, in 2013.
Yeah, I'm familiar with Speedy. Yes, thank you.
Okay, yeah. But in our area, I haven't found any kind of this indicator.
Okay, great, thank you. So I think that we've asked you plenty of questions, and now you can have a bit of a rest. So let's all put our hands together for our speaker for today. So thank you very much.
Thank you very much.
Especially so soon after Diwali, I apologize. So thank you.
Yeah.
And so before everybody runs away, to maybe still visit with family after Diwali, just make sure that next week we do have another monsoon seminar. It's, I think, at the alternative time. And I believe it is Anta Clarice Saar who will be telling us a little bit about, I want to say, paleogeographic and paleoclimatic modeling. So again, thank you so much to our speaker today, Praveen Mishra. And I hope everyone has a lovely rest of your day wherever you are. So thank you very much.
Thank you very much, everyone. Thank you very much.
See you next week.
Professor Clift. Yeah. See you next week. Bye.
Thank you very much, Praveen. Take care.
Yeah.